Hello everybody, this is Dr. Eldik and today we have experiment number 8, which is about AC power supply. How to generate AC and how to display AC. We generate AC using the wave generator in the analog discovery board in waveforms, and we display it using the scope. So we have the same circuit like what we had before. The only difference here is that Vs is not DC, it is just AC. So if this is Vs, then we know that this is supposed to be 2 pi f, 2 times pi times the frequency, which is f. Then this means that the frequency is 1000 or 1 kilo ohm. The frequency is 1000 or 1 kilo ohm. The peak value here is 1 because we don't have any amplitude. So the amplitude is 1. Then now we connect the circuit and then we connect the wires. We need to connect the source. The source is the yellow and black, this channel number 1, or yellow with white strip and black, channel number 2 for the wave generator. And to display, we will use two channels, the orange and orange with white strip, this channel number 1 for the scope, and the blue with white strip for channel number 2 for the scope. So let us connect the circuit and see how it looks like. When we want to set up the voltage source, what you need to do is to select AC. You select this AC sine wave. Make sure that the frequency is 1 kilohertz. The amplitude is 1. The offset is 0. You don't need any offset. Offset will add a DC to it. You don't need to add DC. You enable it and you run it. Then in this case, you will have AC voltage. Then after that, you display it on the scope. So let us see when we run analog discovery board and waveforms. I connected analog discovery board and here is waveforms. So let us open wave generator. And then we need only one channel, then we can disable this one or remove it. Okay. So the frequency here is 1 kilohertz. The amplitude is 1. The offset is 0. And it's a sine wave. Then you enable it and run. So now it's running. So now you have 1 sine 2000 t in the input. The next you need to open the scope. This is the scope. And make sure that you have two channels. This channel number 1, channel number 2. So both of them are running now. Okay, channel number 1 is the input source. So it should be the same like the source that we have here, the wave generator. And channel number 2 is the voltage across the 4.7K. Okay, so we need to run both of them. You can set auto set. This will help you to auto set, to put the auto set for the two channels. Okay, and then you can also select these values here. Okay, the first one, let's me put this one. The first one is the position. We don't need this one. Make it 0. But here the base here, how many seconds or milliseconds or microseconds per division. Okay, here it is 1 millisecond. So it's very clear that the period is 1 millisecond. This period is 1 millisecond, and it makes sense because the period is 1 over the frequency. If the frequency is 1000, then 1 over 1000 is 1 millisecond. If you want to display only one signal, then in this case you have 1, 2, 10. You have 10 divisions. Then you need to make this, instead of 1 millisecond, make it 100 micro. So 100 micro times 10 will be 1 millisecond. So let us select this one here. See, 100 microsecond per division. You see, we have only one period. If you want to make it 2 periods, then you can make it 200 like this. Okay, let's close this one. Don't need this one. And sorry. And then for channel number 1, there's no offset. You see, it starts from 0 here. It's around 0. This is a orange one. And how many volts per division? It's 1 volt. So it is 1 sine. You see, 1. So I will choose 1. And for the second one, there's an offset. If you want to compare them, you have to put them, both of them, in 0. Okay, so now you can compare them. But of course, you have to select also the range. How many voltage per division. So you can make, for example, this one the same like the previous one. This 200 makes this also 200 milli. Okay, so now you see every division is 200 milli, which is 0.2 volt, 0.4, 0.6, 0.8, 1. So this is the input. See, is 1 sine 1000 t, and this is the output, the blue one. So now you can clearly compare because they have the same scale. They have the same scale. Okay, so this is how we set the oscilloscope. What you need, of course, is to take a picture for this one, or scan. Just try to take a picture for this one and add it to your exercise report. So let's go back to the slides. So here, this one again, this is just the source, and then you for the scope, channel number 1 is to display VS, and 2 to display VO across 4.7K. And this is tell you exactly what I did in the scope. That you set the time, channel number 1 and channel number 2. Then after that, you do the same using auto B2Spice. We need to work on B2Spice. How can we do the same circuit in B2Spice? Let us see how can we do this in B2Spice. So we open B2Spice. There it is. Okay, this is the last circuit we did before. Okay, let's just remove this. We just need to connect resistor here and another resistor, and then we need to remove this source and connect this resistor here and connect wire. Okay, so now we have almost the same. You have three resistors. Okay, let's set the value 2.2K, 6.8. This is supposed to be 2.2K. This 7.8, this one is supposed to be 10K. This one here is supposed to be 4.7. It's very easy to edit. Double click and change the value. Okay. Now let us do the source. Okay, this is the only difference now between this experiment and the previous one. Here it was 5 volts. So let's see what we need to do. Double click it. We don't care about this one here. Okay, because it is sinusoidal. Select sinusoidal because it's not constant. Okay, so this is step number 1. So in this tab here, we select sinusoidal. And then you go to the second tab, which is transient properties. And then you set these values. So offset, peak frequency, so on. The peak is 1, so don't change this. Or if you want to change it to 1.5, for example, assume it's 1.5. Set it, write the number, and then accept. So now it is 1.5. But it is actually 1 volt. Okay, so let's make it 1 volt and accept. What is the frequency? The frequency here is 1 meg. You want to make it 1 kilo. 1 kilo. Okay, so accept. So now it is 1 kilo hertz. You don't need to change any of this. And then that's it. This is all. So now the source is set. See, even if it is 0 here, don't care because it is sine wave. Then what's next? We need to do what? I don't. Okay, okay, here it is. Okay, so what's next? We need to go to simulation. Go to setup simulation, and then make sure that the .op is enabled, and you need to enable transient and Fourier analysis. Okay, then you go to transient and Fourier analysis, and you set up here the stop time. Okay, according to this circuit, sine 2000 t is or sine 2000 by t. This is 1000. The frequency is 1000. Then the period is 1 millisecond. So if you want to display two periods, for example, then you set up the time to be 2 milliseconds. For example, you can make it 1 milliseconds. So if you want to display only one period, 1 millisecond, two period, 2 milliseconds. Okay, and then you hit OK. Now you can run. Now you can run. Before you run, you need to know what you want to display. You want to display what? You want to display the voltage across the source, which is 9. You see node number 9. And you want to display the voltage across 4.7, which is number 6. Okay, so you need to run the simulation. Here you see there's no active plots. If you see this this command here, then what you need to do is while it is in the top, you go to edit. While it is in the top, edit, and then edit plots. Edit plots. Okay, and then you need to generate, for example, some signals. What do we need to generate? We need to generate V9. This is the source. Then you add it, and then V6 you add it also. So now you have V9 and V6, and then you say OK. Now once you hit OK, you will see this is the signal here. This is the input and output signal, which is very similar to the ones that we got in waveforms. Okay, so if you look, compare this one with the one that we have with waveforms. Let's see. Waveforms is the scope here. So this is the input and output, the waveforms and the scope. They are the same. They are the same. Okay. Now, if I wanna check in B2Spice, what is the amplitude? For example, you need to select here. You have two signals here. This is number the red. This one is the red. So you select this one. Select. Okay, come on. Here it is. This is the red, and this is the orange. So the red, if you want to know, for example, the maximum here, you try to go to the maximum and click it. Okay, and now you can display the minimum. The value is 999.96 millivolt, which is almost 1 volt. Okay, if I want to check what is the value here, the maximum value, it is written here. It is actually 172 millivolt, which is 0.172 volt, almost. Okay, if you want to select number 2, select like this. You can edit it, of course. If you want to edit it, you can go and edit the plot, and then you can change change anything in the let's see here, edit graph settings. You can change the thickness or anything as you like. Then what you need to do is to take a shot of this picture here and add it to your report.